Green chemistry, also called sometimes sustainable chemistry, is the area of chemistry that focuses on the design of processes that minimize the use and making of hazardous chemicals. One of the principles that guides key chemistry is the concept of atom economy. Let's take a look at what it means. Atom economy is a concept that assesses how efficient it is in making a particular product. Let's say we have a chemical reaction, and the product I'm interested in making is this chemical called phenol. Atom economy also gives me some indication of how much waste product there is. In this case, the other two substances that I make would be considered waste or byproducts, as the atoms aren't being used to make my valuable product. To measure the efficiency of this process, we use the following relationship. Now, this comes from your IB data booklet. Now, some textbooks differ slightly in this formula. On the bottom, some of them may refer to the mass of products. That's not really an issue, because if one applies the law of conservation of mass, the mass of products and the mass of reactants should be equal. I'm going to use the definition that's in your IB data booklet. We're going to look a little bit more closely at the manufacture of phenol. Phenol is particularly useful in the manufacturing of dyes and also medicines. Early processes involved reacting benzene with sulfuric acid. And then in a second step, the product of the first reaction was then reacted with dilute sodium hydroxide to produce the chemical that we want, the phenol. If I add these two equations together, I can come up with the overall reaction. Now the Dow process, does the following. We begin with a substitution reaction and then react it with sodium hydroxide again to produce our phenol. Adding these two steps together, we get the following reaction. So we have two processes to make phenol. I'm going to assess which one shows greater atom economy. To do that, I need the molar masses of all of my reactants and the molar mass of my desired product. I then place them over each other and multiply by 100. So my first process is considered to be about 37% efficient in terms of its atom economy. 37% of the atoms that are in my reactants end up in my valuable product. My second process, again, I look up the molar masses of all of my substances and apply the formula, and I get a process that's almost 50% efficient. 50% of the atoms in my reactants end up in my desired product. This would be considered, at least from an atom economy point of view, the greener method. Thanks for watching. Questions are always welcome.